Mathematicians, most of them are professional. They spend most of their life in this career, in this field, trying to figure out the theorems and solutions for a lot of problems. But unlike them, Jean, Robert, Argand is very different. He's just an amateur like us. But before that, let's look at his picture. That's his picture, okay? Jean Robert Argand was born in Geneva, Switzerland in 1768 and lived and passed away in Paris in 1822. He was a bookstore manager, not a mathematician, but he pursued mathematics as his hobby. He also known for introducing Argand diagram, which is a graphical representative of complex number and also proof of fundamental theorem of algebra.
Hello, I'm Nisa Shakira.
I'm Farah Nadia.
Okay, so I'm going to relay our contribution to ECC 3001. Okay, this is the equation which we call it polynomial equation. Okay, after we had done the solution, okay, this is the full solution, and you get 5 minus 2j, and this is the real number and this is the imaginary number. So I pass it to Farah.
Based on the equation that you get, you can plot the Argand diagram. This is imaginary axis and this is real axis. The imaginary axis is negative 2j, so you can plot the negative 2 and 5 in the real axis. For further information, you can plot the polar. You can use polar form. This is the equation. Okay, that's all from us.
Thank you.
Next,
problem solving.
Okay, the information of the question is actually in the figure below, in the figure beside here. Okay, first, in order to find the Vs, we need to find the impedance because V equal to Iz. Okay, next, to find total impedance, we need to sum up the impedance of inductor, capacitor, and resistor. Okay, firstly, we need to find the impedance of the inductor. Okay, by using the formula of JWL of the reactant inductor, we will get the answer of J30 ohm. Therefore, the impedance inductance is J30 ohm. That's the same. Okay, next is the capacitance reactant. The formula is as in here. The answer is negative J33.33 ohm. Therefore, the impedance is the same. Okay, next is the reactant of the resistance is 100 ohm. It is the same for the impedance. Therefore, to get the total impedance is the summation. The answer is 100 plus J 3.33. Thank you.
Okay, the evidence that we got that is in the rectangular form. So we want to change the answer into the polar form. So first we draw the Argand diagram, but in electrical engineering we call it Bessel diagram. So both technically same. So after that we plot the information with his with the resistance and that. After that we use the theorem of Pythagoras in the answer. Okay, and we got the total impedance in the polar form. So after that we use formula V equal to Iz, and we times the current with the impedance, and we got the answer. So the answer is 100.1 with 1.9 negative 1.9 degree.
Firstly, in polar form. Polar form cannot not only can be defined as imaginary and real parts, but also can be defined as its argument and modulus.
In my tip of opinion, my one is vector form. Actually, vector form is slightly like about the polar form. We have the argument, we have the modulus as well. You have a say in that, Lex?
My one is Julia set. Okay, Julia set is very complex representative of complex numbers, and it's usually used in image signaling. You?
Complex power. Okay, power is
three elements for power and parent power and reactor.
As in G1, express that Riemann sphere, which we can also call it as an extended compact plane. And by Riemann sphere, we also can make it as algebraic geometry.